to give it like another 2 minutes here. See if we have anyone else that comes in late or anyone that joins in on the live stream today. Go ahead and grab one of the kits off the back. One of the green kits off the back there for each one of you. We'll definitely be using some of those today. Okay. Go ahead and close it on behind you. Thank you. All right. So we'll get started here. Okay. So today we're going to talk about more rocks. So last week we talked about igneous rocks, right? You guys remember this? Okay. All right. So when we talked about igneous rocks, we talked about the various types of the composition and the textures of the rocks, right? So you guys remember the chart? All right. So, all right, it's gonna be your vein here for a little bit before you go through it again. Because we're gonna do a little quick review of these rocks. Let's do orange. Okay. So remember the chart, right? That chart. All right. So you got a big old square here. Okay. All right. So we're gonna see here. Okay. So where did we put our composition? What's the axis did we use for our composition? Which one? Like middle. Well, it's like we're labeling the entire. Which axis is which? Because one is going to be compositions and one is going to be texture.
Okay, so you got sample number, texture, composition. Rock.
So this axis would be
the sample, the rock.
Texture or composition is what we're looking for here. Whichever one. That's what we're going to put here. Which axis do we have here? Because remember we had. Yeah. So. This axis right here, do you remember what those were? So we had like the pyroclastic was one. It's here. Texture. Yep. Yeah. Texture. And then you were saying samples, right? So we're going to come back to the samples because that's what's going to start filling these in. That's what we're going to start filling these in with. So we have texture. All right. And that means by process of elimination, we have composition up there. All right. So, hey, real quick, what's a rock? Real quick? So you on the test. First question. Along with what's a map?
A compound of minerals.
There we go. Compound, aggregate, anything. Basically, it's just a big old mixture of minerals. Awesome. All All right, so we now have to label our compositions. So we have 3 compositions. What do we got?
Felsic.
Okay, very good. Very good. So felsic.
Basic.
So what goes here?
Basic.
Keep going. You're
Intermediate.
Hey, very good. Intermediate. All right, and then yes, basic. Very good. Okay, so now we have the challenge of filling in the multiple types of textures. So the first one I'm looking for is going to be small crystals. So what is that? Small crystals, right? What is the term we use for small crystals? Hey, that's the stuff. Yep, aphanitic, right? Very good, very good. So we're going to call them for a row for aphanitic, right? Okay. And then the next one I'm looking for is big crystals. What do we got? Anaritic. Very good. Okay, so the next one I'm looking for is when you take those two and you mix them together. Right? So you have like, remember that we had one, I showed you rhyolite. And the rhyolite had this salt and pepper texture because it had larger crystals encased. Porphyritic, very good. Yep, it had larger crystals encased within a much more populous, smaller crystals, right? So we have porphyritic. All right. So we're just going to get that one here. So, okay, there are 2 more. There are 2 more. What do we got?
Pyroclastic and glassy.
So pyroclastic and
Glassy.
glassy. Very good, very good. Not sure if you said that the first time. I'm sorry, I didn't hear that. And pyroclastic. Actually, I'm going to separate that one into 2. Okay. Now we have to fill this out. All right. So a felsic aphanitic rock means, and I know that you could just tell me what it means, like what the rock is, but let's break this down. So a felsic aphanitic rock means that it is, what is its coloration? Start with that. What is its coloration? When something is felsic, how can a rock tell you that it's felsic? Coloration. What do we got? So, okay, not quite, we're getting there. So a felsic mineral. What you got? I know you guys know this. All right, because the labs are very good, quite good. All right, so a felsic mineral is light in color, right? So what does that mean? That it is high in what type of materials? What was that? Yes, perfect. Yep, silicates. That's right.
Yeah.
So high in silicates and low in iron. Okay. But if it is aphanitic, it means that it has small crystals, right? So what goes here? This is one you guys gotta know.
Rhyolite.
It's the one you guys gotta know this one. All right. Now this one. So intermediate. Intermediate means that it is not. It is neither too light or too dark, right? So that tells you that it is probably, you have like the really dark basalt, which I showed you guys before, right? And the really light rhyolite. But there's one that falls in the middle. I think I mentioned I didn't like this one too. Andesite, that's the one. Yep. All right. And I think I gave it away here. So small crystals, very, very dark, very, very dense. That one is basalt. That's the one. All right. Okay. So again, remember, moving down to the next column, we know felsic and phaneritic. So phaneritic means large crystals. So let's review this real quick. So what is the difference between aphanitic crystals and phaneritic? What makes the difference?
One cools internally,
Very good. Yes. So yes, one cools. So which one cools externally or extrusively? Very good. Yes. So aphanitic. Good. Yeah, my voice carries, man. Honors people across the hall have heard my lectures enough. So yes, aphanitic. Aphanitic means that it has small crystals, and that is because it cools rapidly. Very good. Very good. So as opposed to phaneritic, which Xavius, yes, you're right. It cools intrusively, which means the crystals have more time to congregate with one another and come together. And so we have a felsic, a phaneritic rock. So we know that it is fairly light in color, okay? But has large crystals. This one's pretty common. Which one's this? Granite. That's right. All right. Now this one right here, is also one where we see countertops with this. And between this one and the next one, these two are always very difficult sometimes to distinguish from one another. I will pull out samples of that at some point here. But yes, intermediate. So a mixture of lighter and darker materials. Okay. But phaneritic with larger crystals. What do we got? Diorite. Very good. Okay. And this one. So mafic. I think this was the one I said is the most missed. Yeah. So gabbro is culprit. All right. Okay. So porphyritic. So what is special about porphyritic materials? I already kind of mentioned it, but what is special about, how is a rock porphyritic? How is a rock porphyritic? Like, what makes it that way? We talked about this.
That's like mixed crystal size.
That's right, because it cools
Rapidly hit the surface.
after what happens? Okay, very good. But there's a process that happens. Like, yes, you're right. It does erupt and come outward. But remember, the crystals are a mixture. So there is cooling that happens inside the earth before it is extruded and is completely cooled. So if we have a rock that is porphyritic, we are not looking for just one rock. We would definitely just call it a porphyry. Porphyr, that is always hard to spell. So we're just going to go with that. Okay. So this way, what you can do is you can say, I have porphyritic rhyolite, or porphyritic basalt. So that is not one rock by itself. That is used to describe a trait of a rock in general. Okay, so glassy. This one's easy. What we got? Glassy texture. Obsidian. Why is it glassy? What makes it glassy? What process occurs?
Instant cooling.
Instant cooling. Very good. Yes. So it's obsidian, dragon glass. All right. Okay. Pyroclastic. I have separated into two sections here because there were two samples that I gave to both of you. So pyroclastic rocks. What's this mean? Fiery chunks. That's right. So basically a chunk of molten material that is just tossed through the air and is either cooled during that process, or there's another rock that forms from kind of a foam that comes off of lava. So there's one that is really light in color and also light in weight. And I showed you guys this one last week. Both of these samples have, when I showed you both of these samples, they both had like air holes, right? Do you remember what they're called? What's that? Yes, very good. So let's go with, it's one of those air holes called that distinguish some of these rocks from one another, that say that this was launched through the air. Start with a V. Vesicles, very good, very good. Yes, so vesicles, right? So vesicles, air holes. Okay, the other one, so you got pumice. The other one was a very dark looking rock that was thrown through the air and had lots and lots and lots and lots of vesicles. You guys remember what this one was called? Scoria, very good. Okay. So again, this chart by itself won't be able to test, but this is an extra credit assignment that is on its way. So you know, sorry we're going through this again. This is an extra credit assignment that's on its way. I think we're gonna put it up this week. But yes, this is, and we do this, and we might do this again before the test to help you guys understand the difference between what each one of these is and how they interact with one another. So, felsic, aphonetic, felsic, phaneritic, and so on. Hopefully doing this continually will help reinforce this when you guys get to the midterm, which I think is 2 weeks away, I think. So, yeah, we'll have that to talk about here pretty soon. But, oh, sorry, those of you at home, you guys see this okay? Let me step out of the way. I guess I should probably find where I'm at from work today. Right. Hello, also, if you are here in the live stream, please put your name in the live stream so I know you are here. So, please do. Or if you're just got me playing in the background, please come back and type your name. That's fine. Okay. All right. So, the igneous rock lab, how do we feel about that? How do we feel about that? Yeah? Okay, yeah. You guys did very well. Very, very well. So, just wanted to do a little bit of reinforcement before we moved on to the sedimentary rocks. Because while igneous rocks are about understanding how things cool or the location of magma or lava, sedimentary rocks are about the process. And that's what we're going to get into here today. Sedimentary rocks are a process. That is something that happens through various steps. So go ahead and open your lab manuals to... Okay, well, for me, this is lab 9. And I know that's not... No, sorry, lab 10. That's not lab 10 for you guys. Open it to lab 5. We're just going to go with that. Thank you, Noah. Are you guys good with this? Okay, cool. So I don't know why it's so cold in here. It's usually swelteringly hot. All right. Okay. So, sedimentary rocks. All right. So, is yours just sedimentary or is it metamorphic also? Just sedimentary. Very good. Mine's sedimentary and metamorphic, but nope, we're just doing one. All right. So, sedimentary rocks. So, let's start with this. The word sedimentary. So, think of sediment, right? You walk into let's say some I don't know, you go swim in a river, which, you know, is varying degrees of safe, but swimming in a river, you put your foot down in the riverbed, and sometimes your foot may sink, or it may feel like the riverbed is kind of swallowing your foot, right, depending on what the sediments are. Or you might put your foot in the riverbed, and ouch, there's a bunch of rocks down there. All right. So those sediments are things that have been broken down from other rocks. Can tell you that every single inch of dirt, every single rock that you pick up that is not igneous has been broken down from other material, right? Through various processes or through perhaps multiple times, but that is what sedimentary rocks are all about. It's about the process. So have you guys talked about this in class? Yes, sedimentary rocks. I know you talked about the rock cycle, right? Yeah, listen, we ain't going through that. You go through that. I know. Do you guys have to memorize that? Ooh. Oh, question. Do you guys have class before this? Okay. But you did?
Oh wait, come on, today?
Yeah.
Oh.
Okay.
Monday and Wednesday.
Okay. I thought somebody told me that they had geology class before this, and I understand how. I wanted to ask because it might be my other class, but I wanted to ask because I know how that can be coming from a class to another class, but then it's the same thing over and over. So I would hate to, try and I don't know, maybe like do a song and dance, make it more entertaining, or I don't know, find a beach ball and try and balance myself on it, which that would be bad. So, all right. So the process. Sedimentary rocks are a process. We're going to talk about the varying steps. So I'm not sure how Dr. Martin taught it, but I like to teach things in a simplified manner is what I like to do. I like to simplify it and break it down so it is more digestible. So we're going to start with the very first thing you do. So when you have a rock, right? When you have a rock, let's take, we're going to refer to this sample quite a bit. So I'm going to first show this to the people at home. So this is, yes, this is a conglomerate, right? So you'll see this rock has a bunch of different rocks in it. So varying types of particle sizes. So we've talked about particle sizes with the volcanic rocks. But we also have, what's a sandstone? We're going to come back to this one, right? But the problem with sedimentary rocks, sometimes you can have the same rock that looks completely different. You can have the same classified rock that is something completely different. And I think I showed you guys that with igneous rocks. I think I showed you guys, did I show you the 3 types of granite that I had? They were all the same granite. Did we do that? Okay, yeah. One was like kind of reddish and orange. But regardless of that, you can still tell the traits of the rock. You still can look at it and go, hey, that's granite. It has something like mixed in there, but it's still granite. Where sometimes with sedimentary rocks, that may not be as apparent. I'm not going to show the people at home. So the 2 conglomerates, but they are very different in both color and texture. Okay. All right. So the first start making a sedimentary rock, you need to weather it. You need to weather it. So the way that we're going to talk about weathering, let me get a different color here. Weathering. One of these works, but one of these doesn't. 50-50 shot. I don't know why I kept limited. Okay. Step 1. Weathering. So when you weather a rock, you can do this in 2 ways. And we are not going to go very deeply into the chemical weathering. I feel like in class you probably got a really good talking about like how they can ionically bond to certain other, I don't know, I'm not a chemist, but the physical weathering is the important one. So physical weathering comes in many different forms, but one thing, you can weather a rock by yourself. You've seen me do it a bunch of times. You have seen me weather a rock, well, hopefully almost every class, because I try and do it every class. But this piece of sandstone right here, right? Sandstone's pretty easy to weather, right? And you can weather it, right? So I've weathered the rock, okay? Especially the people at home, they get the, yeah, see, that's a weathered rock right there. So that is mechanical weathering. I have mechanically weathered this rock by taking parts of it and breaking it down. And now parts of this rock are somewhere else and will end up somewhere else. So don't worry, I have a much larger one back there. One of those days I'll take that and just like, but not today. I'll wait till the last time I teach it. Okay. So we talk about when we talk about weathering, we talk about the particle sizes. What do they break down into? And this is important because what they break down into can determine how far the particles that are broken down travel, or how easy they are to turn into another type of rock, right? You guys talk about the various measurements of rocks, like the measurements of the particle sizes. Okay, cool. Well, we're going to do that. So, when you mechanically weather a rock, right? Mechanical is first. You break it down into 4 particle sizes, and this should be on, I don't know, hopefully the page right after the first one, because mine just jumped right into weathering. So
would that be the same thing as physical?
yes, yep. Gravels, sands, silts, and clays. Okay, so on the test, this will be a matching portion on the test. Every time I put this on a test, I make this a matching thing. This is in size, sort of descending. So, if you go into the test, you can say gravel, sand, silts, and clays. Gravel, sand, silts, and clays. Gravels, sands, silts, and clays. I'm probably going to repeat this back to you 100 times before the test. Gravels, sands, silts, and clays. That will help you. If you just know the order, gravels, sands, silts, and clays, you will be able to ace that part of the test. So, like I said, this will be on there, and I'm going to put the particle sizes up here. But if you can just remember the order, you've got it. That's all you got to do. All right. So let's go through the sizes. Let's use. Okay. All right. So gravels are 2 millimeters or larger. All right. I know we measure in freedom units here, so I am going to give you guys examples of this, right? This is gravel. This is gravel. Look at some of these larger, they're almost rocks on their own, right? That is a particle size that is 2 millimeters or larger, okay? All right. Next, is sands. Is it 0.05 or 0.5? It is 0.05. Yeah, it is. 0.05 millimeters. So that is this sand, right? So you've all about sand. Here, have some sand. There you go. That is 2 millimeters to 0.05 millimeters. So here, you have some. Yeah. I don't know. Here. I have to clean these tables after, so I'll probably just. That's it. You're also that too? Okay. All right. That is safe. And the reason why I try and pass around samples of this stuff, or give you an idea of these sizes, is because you can't really get a good idea from me just telling you the numbers, me regurgitating numbers to you. It doesn't, it just can't stick in there. I get that. So it's good to have important milestones or markers as you go to, like I said, on, I think you might do this on the, you actually won't do that on the Turnitin assignment. You're going to do identification. But 2 millimeters, 0.05 millimeters. But next, we have silts. Get the right zeros in there. I think I did. I did. All right. So silts. Silts. Actually don't have a good silt stone to break, which is kind of sad. It's always more fun when I can break them. All right. So silt, when you think about silt, I'm going to write this down because there's one. Think about flour. Right? Your working flour, very fine. Sometimes small enough that it can get in your, your fingertips, in your, your fingerprints, the grooves, right? It is fine enough that it can find its way in there. So, silts are 0.05, 0.002 millimeters, and has a consistency like flour. So, I didn't put the ones for sand up there because sand has a consistency of sand. Gravels, well, All right. Silts, I'm not sure what it says in your manual there, but yes, you really can't feel the individual particles of silt. Not like you can when you put your hands in the sand and you're like, oh, yeah, you can definitely tell. So, all right. So, okay. So, all right. So clays. So clays are 0.002 to a single molecule. All right, 0.002 to a single molecule. Thank you again for weighing in, letting me know you were here. Awesome. All right, and clays. So clays can have some kind of strange properties depending on the size of the clay, but sometimes acts as a way to bind. It binds. So what do I mean by that? Well, let's look at this rock here again. So I'm going to show this to the people at home. This rock right here again. So the particle sizes of this rock, I like this one because it has all four. I'll pass this one around here pretty soon. This one has all four. So we have the gravels, right? So we can see that, the larger pieces. You turn it over and you see that it's got this rough texture. There's your sands. And a lot of what's holding it together, you can see there are some other smaller pieces like silts, but it gets a little harder to see. But the the clay part, you can see where some of the other rocks used to be. There are grooves here, right here, where some of the other rocks used to be. And it's very smooth. It's very smooth. And that is where it was held together. It was bound to the conglomerate here. So, here's what we're going to do, actually. You guys want to take a look at this one? All right. Okay. So, we now have the four particle sizes, and again, you will see these on the test. This will be a matching section. Gravels, sands, silts, and clays. This is one of those that you can get that mantra going in your head. Gravel, sand, silts, and clays. You will, much easier time will be very easy because if you know the order, all this numbers, all this numerical stuff, doesn't matter. As long as you know the order. I know the numbers tend to trip people up, and I understand that. I'm not very good with numbers myself, but try and get the order, and you will be fine. So remember, mechanical weathering is something that happens as a result of a physical process. It's a result of a physical process. Okay. But we have chemical weathering. Chemical, right? Chemical. And chemical is when you take it and you break it down almost to its individual atoms, right? So, can anyone tell me the best driver of chemical weathering? Best driver. What's that? Rain. Very good. Water. Yes, water. So, water. All right. Yeah, so mechanical is a result of a physical process. So whether it be wind or some other thing, and it can also be water. Water can also be a driver of mechanical weathering. But think of it as in like water just breaking down, like quick water or moving sediments through and it's just rushing against something else. But water is more about chemical weather because it breaks things down, right? And so what happens with the chemical weathering, it breaks it down and it reforms it into something else. We're not going to go too deep into this because we talk more about the physical process here. So we're not going to talk a lot about the chemistry behind this. But if I talk about chemical weathering on the test, I will most likely be talking about water also. The two will go hand in hand. So. All right. So after you've weathered a rock, after you have weathered a rock, what do we do? Well, how do we make another rock? I mean, you can weather it and then it just kind of hangs out, right? Or you can transport it. So, transportation. Let's do number 2. Let's keep doing this color. All right. Transportation. Okay. How does one best transport a rock? How does one best transport a rock? How do you do it? What's the best way? A weathered rock. So we break it down, we weather it. What's the best way to transport it? Okay. Very good. What else?
A river.
Hey, that's good. Yes. So water and gravity. Water and gravity. So you're going to have those two are the best ways that you will. You put in water in blue. Water. Gravity. Water and gravity. So you have, a lot of times these processes are tied to one another. The water may have actually broken down the rock itself and also transported it. And this is where we get into, I'm not sure if you guys talked about like how it turns into a solution when you do it chemically, right? How you can have like what's called the solution load, and what happens is the solution load is basically the water that is full of these molecules or these atoms that have been broken down, and that transports it somewhere else in a solution and deposits it somewhere. So, okay, any questions so far? Yep. Oh crap, batteries running low. Hold on. I mean, I know that it's a lot to throw at you at 10 in the morning because I only woke up at 9:30, so good. I mean, no questions so far. Very good. That tells me one thing, or two things. I'm either really good at this, or you guys are really tired. And I think there's a 50-50 shot here. I don't know. Hard to tell. I also taught this a lot, so who knows? All right. Hey, yes, thank you. Sorry, I need to pay more attention to those of you in chat. Yes. I'm so sorry. I do see you here. Yeah. Okay. All right. Let's take 5 minutes before we do this. People at home, get a drink. Take a minute. I'm going to do the same. Take a breather here because I'm about halfway through. And we're going to get there. So people at home, give me like 5 minutes. Guys, like take 5. Let's just get something to drink. And we'll come back since we're only about halfway through.
equipment was immeasurable for the day's drive. What did Norm say?
All right. There's sand everywhere now. I've done this. Everyone at home who's watching at home, follow along okay? You able to see everything all right? No? Okay, all right. Let's guess we'll jump back in. Okay, so we have weathered it, transported it, and now the next step is making a sedimentary rock for it to get deposited. So what will happen is it will reach a point where the energy that is transporting it runs out. It might no longer have the ability to travel any farther, maybe whether it be by river or maybe even an aeolian process like wind, so on. Might not have the energy, so it will find a place to rest, and then it will start forming into a rock after it is deposited. So 3 deposition. Deposition. All right. And it says that they are deposited whenever the water slows down and loses energy. But this happens most commonly when a river meets an ocean. So when a river meets an ocean, there is a particular landform that is created typically when the river no longer has the energy to push out that sediment. So if you go to the Mississippi, right, and you were to go to where the Mississippi meets the Gulf of Mexico, you are in, there's a landform, you've heard of the Delta, right? The Mississippi River Delta, okay? And that is where, that is a point where there is a lot of deposition that has occurred, and there are a lot of landforms that have been created from the water that has brought all of this sediment, and the sediment has come to rest and has created landforms, but that is very dynamic, and it always keeps changing and moving, and sometimes things will be re-transported afterwards, right? So deposition is finding a home. Breaking this down to the simplest of terms is basically just finding a home. Okay. And I think this is the last one. It is. And 4. Lithification. So, lithification is becoming a rock. Becoming a rock. So, there are 2 ways to start it. 2 ways. All right. What is sedimentation and compaction? Sedimentation and compaction. So, these two are 2 different processes that help create the rock, and I'm going to show you an example. So, this would be rock here, conglomerates, are when something is cemented. This is when something is cemented. So this is when smaller particles come together and bind together larger ones, or bind together to form various rocks. And these rocks come together and are trapped and cemented into one another. Right? Whereas things like, actually, I have a better example. I might want a kid. Hang on. I'd love if you wanted to actually have like. It's okay. We're going to use the examples. But compaction is when something is squeezed together through weight. And this happens when you have sediment on top of sediment, on top of sediment, on top of sediment, and what starts to happen is the combined weight just squeezes down upon them and creates a rock. Whereas when something is cemented, things come together and are bound together, sometimes through chemical processes and sometimes through mechanical. But that's the process. This is the process of sedimentary rock. So it goes from, so you have a place where I'll tell you the river that the Mississippi comes from, but there's a lot of sediments that you can sometimes find in the upper parts of the Mississippi that have run down to the southern. So what will happen there is it will weather, and it transports, right? And when it no longer has the energy to transport, it deposits, right? So it finds a place to call home. And then it will lithify. Okay. Any questions about this process? Now you know. Okay. We're about to go into some rock identification. Got some rocks. Open up your kits. All right. There's. Okay. So, some of these are pretty good examples. I think the conglomerate examples are better. The ones I showed you were a little bit better, but that's okay. All right. So a conglomerate. That is the first one on the list here. Conglomerate. So at least 51% gravel. All right, so you'll see that it is these. That's number 29 in your kit. These samples are okay. I don't think this sample makes it very easy to see, but it's okay. All right. Red sandstone, number 30. Hard to miss. So it's reddish rock, right? Red sandstone. So sand-sized particles. It is gritty. It's not a mascot from Philly. That is texture of this rock. It's very gritty. All right. And has an iron oxide is what gives it its color. Okay. But a sandstone must be at least 51% sand. I know that seems like that would always be the case, but I have one that's 49, and that's not sandstone anymore. But this is a nice, great example, number 30 of a sandstone. All right, number 28. Wait, no. Number 28 in my kit is something very different. Skip 28. 32, argillaceous shale, or argillaceous sandstone, sorry. All right. So this is 51% sand, okay? But it contains a lot of clay. So when you hear the word argillaceous, argil, clay, argil, clay. All right, so this is basically almost the same thing as number 30, but they just have different things in them, right? So number 30 is mostly all sand, but number 32 is when you add a lot of clay to the sand. All right. I don't have a good example of shale. I didn't look for it, but we do have. You know, does your lab manual do this? I have argillaceous sandstone and argillaceous shale with the exact same number.
Mm-hmm.
Yours does too? Okay, so I know mine's an older version, so I see that. That slipped through the editor's neat. Upon further inspection, I think this one is the shale. I'm actually sitting here looking at it. Go back to 32. 32, argillaceous shale. This one, 32, is the shale. Should have went with my gut on that one. All right, room for argillaceous, argil, clay. Actually, let me write that down. Because argil, you see this? Oh, God, I can't spell. Clay. Okay, it's that kind of morning. All right, argil, clay. Okay. All right. Limestone. I think we've all seen some limestone, but here's a good sample. This is limestone, right? So limestone is a chemical. This has been weathered chemically and is at least 51% calcite, calcium carbonate. Okay. All right. Just says you will not see any fossils, just shiny crystals of calcite, which this one isn't too shiny. But okay. Let's look at number 34. Number 34. I feel like that's also misleading. What's your number 34? Let me see. What do you got there? Number 33 is mislabeled the book. Shell limestone. Shell limestone. All right. So this is what happens when you have a rock that is formed, that is made up of number 30. It should be 33 instead. Yeah, I noticed there's an error. Another one of this manual here. This was created by organic means. Created by organic means. So this is what happens when you have ocean creatures in the ocean, shellfish, or things that make their home in the limestone, and you get these. Yeah, it's really neat. Like, there's some fossils in there. There's some really cool, like, pieces of shells and stuff. But all right. Okay, chalk. Chalk. Hang on. This one, I have to use this. You know, do the big right with it for a whole class period. This is mega chalk. Chalk. So, chalk is sedimentary rock. All right. Also, you get like really bad heartburn and have to like take something for that. Like take like a, yeah, it's chalk. It is like mostly chalk, flavored chalk, but mostly chalk. So, yes, chalk is another form of limestone, and this comes also from calcium carbonate. Okay, typically created by living creatures. It says that the chalk is usually very fine, right? So it has that like flour feel to it, right? So you see it like has some, I'm sure you guys can, yeah. So very dusty, right? Okay. So yes, that's what you want out here. Now we have that on me all day. That's great. Okay. All right. So number 27 is chert. 27 is chert. So. All right. So chert is something we can find here around Alabama. Probably found a few pieces to the south side. You make arrowheads out of this because of the way that it breaks very sharply. Breaks very sharply. So there are probably many weapons in history that were made with pieces of chert. So let's see. Oh yeah, super hard. Super hard. So all right. 35, sample 35. Bituminous coal. Bituminous coal. Okay, so coal is different from other rocks, right? Due to one thing. You guys know what this is? What makes coal different than everything else? In the way it's makeup, right? You guys know?
It's biological.
That's right. Coal started as something biological. So, which is kind of cool. We talk about a lot of the coal is made from compaction, and I'm not sure if your sample has it. My sample has some really nice, like these lines that you can see running through the side of the sample. And when you see lines, that generally means something is pushed down upon, so or has been formed through some uniform process. But some of these have these really neat lines that show you where it was pressed down to create that coal, where the weight of other material on top of that biological material came down and created that coal. So, also, given how much coal we use as a species, it gives you an idea of like there has been life on Earth for a very long time before us. So we have a lot of coal to use. And we're only talking about bituminous here. We will probably talk about anthracite coal a bit later in another lesson, but we're only talking about bituminous right now. Okay, all right, we made it. We made it to the lab. Okay. Here's what we're gonna do. I'm gonna pick I'm only gonna do 4 of these. Those of you at home, those of you who are watching at home, this is going to be where we part ways because I am not going to make you use the crappy camera that I am using, although it seems to be okay for streaming. But this is also the camera that I used for, if you guys had to watch a video for the last lab for the rocks, it's not great. So I'm going to send you pictures or might wait till next week if I can get you guys in class. But odds are I might find my friend's camera, take some really nice pictures of the rocks, and send them to you. All right. So those of you at home, this is where I bid you adieu. Thank you for showing up. And again, if you have been here, please put your name because it matters. All right. Okay. So, all right. Thank you again, guys. Bye-bye. All right.